Hello friends, this is day 7 of doing Codeforces until I become a specialist. Okay, so today we are going to solve from 18th problem, which is grasshopper on a line. Okay, so what is grasshopper on a line? A grasshopper on a line. Uh, you are given two integers x and k. Grasshopper starts in a point 0 on from point 0 on OX axis. So in two-dimensional axis, it starts from only this OX axis. Okay, we already know this is Y axis and this is X axis, right? So in one move, it can jump for some distance, some integer distance that is not divisible by k. So it can jump in some distance. We don't know the distance, but that distance must not be divisible by value k. Okay. So to the left or right, either of the distance. So what is the smallest number of moves it will take the grasshopper to reach point X? And this is our destination point. We have to reach this X point from 0 point on OX plane. Okay, that is what he said. And what are those moves? We have to mention those moves. If there are multiple answers, print any one of them. Okay. So we have to read the test cases and then we have to read the two values x and k. Here x represents what? Like x represents this the destination which the grasshopper has to reach, and k represents the value for which the distance which is moved by the grasshopper must not be divisible with that. Okay, so and here output, for each output, for each test case in the first line print a single line and the smallest number of moves it takes the grasshopper to reach point X. Okay, first we have to print the smallest number of moves to make the grasshopper to reach to the point X. In the second line, print n integers. Each of them not divisible by k. Okay, those n integers are actually not divisible by k. Okay, we have to print those all n integers. A positive integer would mean jumping to the right. A negative, okay, so here positive, you may get positive or negative. So negative represents jumping to the left, and the positive represents jumping to the right. And each jump distance should be from 10 to the power of minus 10 to the power of 9 to 10 to the power of 9. Okay, I think this is the limit only. Uh, it can be shown that for any solution with the smallest number of gems, there exists a solution with the same number of gems, such that each jump is what he is saying. Each jump distance should be from 10 to the power of minus 10 to the power of to the 10 to the power of 9. Okay. It can be shown that for any solution with the smallest number of gems, for any solution, smallest number of gems, there exists a solution with the same number of gems, such that each jump is from 10 to the power of minus 9 to the 10 to the power of 9. So, uh, we get a solution with the smallest number of gems, and we can there exists another solution with the same number of gems between these 10 to the power of 9 minus 9 to the 10 to the power of 9 interval. Okay, so we don't need to understand all this. We just have to understand what uh, what is the concept, and what we have to take and what we have to give. So here there are three test cases, and in first test case the x value is 10 and okay, okay, the first x value here is 10. So this is our destination, and this is nothing but k value. So okay, we will understand it further. And we are currently at y-axis axis. So this is at point 0, and this is uh, let this uh, let us treat it as OX axis. That means this is x-axis and this is y-axis. There is no need to use of y-axis here. Okay, so only focus on x-axis, and we are currently at here. Okay, so and we have to move to this 10th distance. We have to move to that 10th distance. Okay, and whenever a jump is made, so the grasshopper can able to jump something like y number of distance. Let us say, so its jump the distance is y. Okay, so the distance which is made by a that frog after it jumps is y. So this is whole y. Okay, okay. Now, if this y is actually equal to x, then what is our answer? We are actually moving, get the answer in only one step. So one is our, we have to print one and then we have to print the number of gems forms inside it. So as it is only one, we have to print 10. But here we have a condition. Whenever a frog is jumps and made some distance y, that distance must not be divisible by 2, right? So here, let us say, so it will actually go to the destination directly, jump. But the destination, which is 10, is actually divisible by 2. So whenever it is divisible by 2, what we have to do? We have to just make the frog to jump below the 10, which has to be closest to value to the 10. So nothing but here it is 9. So if the frog jumps 9 distance at if frog jumps makes a distance 9, so let us say this is 9, and this is our destination where it is 10. Okay, so we already go to the distance 9, and you know that 9 is not divisible by 2 because 10 is divisible by 2, then 9 is not divisible by 2. Yeah, is if a number n is divisible by 2, then definitely n minus 1 is not divisible by 2. Okay, so and here we are having one less number to reach to the 10. So only one more, which is actually only one jump. And this one is also not divisible by 2. So this is also true. So we have to return answer like uh, it contains elements, two elements, and one is 9 and another one is 1. Okay, and here it contains a 7 and a 3. Okay, that is also right answer. Here 7 is not divisible by 2 and 3 is also not divisible by 2. So it is also answer. And for 10 and 3, here 10. So the frog first tries to move to the distance on what it tries to match the distance y is equal to the distance x. So but after matches it checks whether the distance actually divisible by the value k. Here the value k is 3, so as it is not matched, then we just return that value along with one more, right? So let's try to implement code. Okay, open CodeChef C++ combiner. Okay, what we are doing, we have to take the test cases. How many test cases? We have to read the test cases, and while on every test case, we have to read two integers, which are nothing but one is x and one another one is k. That is the destination. X is the destination, and k is the checking variable. Let's just say like a k is checking. So uh, what what we have to do? If that x is actually divisible by k is equal to 0, we should do one thing. If it is not, we should do another. So whenever it is divisible by 2, uh, our answer, we have to make, it shouldn't be divisible by 2. The decision which is made by the fog is it shouldn't be divisible by k. So whenever it is divisible by k, we have to understand, okay, we can achieve this in just two ways. So yes, I think you got it. One is n minus 1 and another one is n minus 1. Here that is x minus 1 and another one is 1. So then it won't be divisible by 2 backslash and after that. Okay. If the number is not divisible by 2, then directly read that number is actually the length which the frog made. So which is providing only one gen, and the answer is what? X, because that is the value, right? X. Mhm. So let's try on the test cases. Let's try it on the test cases. 291 110 13 110. Okay, it works. Okay. Just open the panel, submission panel. Okay, it's accepted. One minute. Now, unit array. What is unit array? Given an array A of length n, which elements are equal to -1 and 1. So we have array A and it is length n and it have elements like -1 and 1. Let's call the array A good if the following conditions are held. Okay, what are those conditions? One is A plus summation of all the elements inside A is actually greater than or equal to 0. Okay, and product of all elements of A is actually 1. Okay, in one operation you can select an arbitrary element of the array I and change its value to the opposite. In other words, if I is equal to -1, we have to uh, identify index and change the value inside it into a negation of that same value. If the value is actually the negation value, then we have to change it into inverse of that negation value. It we can say it like we have to remove the negation part. Okay, determine the minimum number of operations you need to perform to make the array a good. It can be shown that visually. So how many operations uh, we need to perform to make the array a good? To make the array a good, how many operations we need to perform? How many operations we need to perform? Okay. Each test case contains here is the nothing but test cases, and n is the length of the array, and a1 a2 up through an up to a the elements of array. Oh, what he's saying? Okay, okay, I got it. So he's saying like For the test case, we have to read value n, which is nothing but the size of the array. And then we have to declare a vector, which is nothing but array a of size n. Okay, and we have to read everything with an array. I think I already know it. So less than n plus plus. So you just have to use this scene and yeah file, which puts the elements into their respective positions. Okay. Here there is only n. Okay. After that, what we have to do? We have to return the minimum number of operations. Uh, as the array only contains -1 and +1s, and it only contains -1 and +1s. And let's observe this pattern again. In the first test case, we can assign that a1 is equal to 1. Then u1, u2, u3, u4 becomes okay greater than or equal to 0. And a1, a2, a3, it actually becomes 1. Okay, it actually becomes 1. Yes, he's right. It actually becomes 1. And in this test case, should we need to change anything in order to make the sum of elements is actually greater than or equal to 0? So like sum of elements is actually greater than or equal to 0. So first law is actually this uh, like -1 plus 1 -1 plus 1 -1, which is actually not satisfied. So we have to remove over here. So here three minuses. Here that minuses are actually greater than minus values are actually greater than plus values. So then we should must change the one minus value, but not actually exactly one. Up to where the minuses and pluses are actually same or greater. But here we can make it we can't make it change, but no problem. The answer for it is actually 0. Answer is 0. Why? If we change this -1 into 1, then the second law is actually uh, like sum of all ones is actually equal to 1. But the first law, which is actually -1 plus 1, it is like accepted, right? So this is 1 and this is 2. Okay, it is also 1. Here 1 means we just only perform one operation. And for this one, we don't need to perform any operation because here total number of negatives and positives are same. Yes, negatives and positives are same. And the third sum all are negatives. So in order to make them into one and summation is equal to greater than or equal to 0, you just have to make them into positive. All are positive, not even single positive can yeah, can't make it as good. So that's why uh, if we only change to those, there are also there may be a chance, right? -1 -1 -1. If we becomes -1 and 1 and 1, so then -1 plus 1 cancel, -1 is only available, which is greater than okay. And second property, -1 plus 1 plus 1. We get answer as -1, not a plus. So that's why we have to change 3. So for that we have to use 3 operations. Okay, and for the test case we don't need to use any operation because summation is actually the same. And for sixth test case is actually -1. We have to use one operation because we have to turn that -1 into +1, then only to operate. equations are actually solved. And final test case minus 1 and minus 1. If it as it contains minus 1 and minus 1, the product is actually 1. And there's some minus 1, minus 2, minus 2, which is not. So that's why we have to perform two operations, two times operations here. That after that we get array like of 1, 1. Yeah, that is how much simple it is. So I hope got the intuition. We just have to find the number of odds and number of integers because that's where the answer is lying. Here, whenever the number of odds and number of equals, I mean number of odds and number of positives. Uh, why I'm saying it is an odd? It is not an odd. Number of negatives are actually equal to number of positives. Where here number of negatives is actually equal to number of positives, then we should return 0. We don't need to perform a single operation there. I think you got it right. And yeah, whenever what if we uh, what if we have three minuses and three pluses, three minuses and three plus minus minus plus and minus, that is actually 0, right? The product has to be 1. The summation has to be greater than 2. So if we 3 minus 1 minus 1 1 minus 1 minus 1, so we get like minus 1 plus 1 cancel. Oh, okay, I got it. So instead of this let's open this point. Okay. We have minus 1 and 1, minus 1 minus 1 minus 1 and 1. So we have same frequency. Whenever we performing summation operation, it gives result 0, right? It gives result 0. Whenever we performing multiplication operation, okay, and which results in like minus 1 into 1, minus 1, minus 1 into minus 1, 1, 1 into 1, 1. So the product is actually 1. What if we have negative number of odd values, but we have same number of even values also, like minus 1, minus 1, minus 1, and then minus 1 and minus 2, minus 2, minus 2. Okay, minus 2, minus 2, minus 2. Here, whenever we're performing addition operation, this minus 1 and this plus 1, minus 1 and plus 1, minus 1 and plus 1, all are cancelled. But when we are performing multiplication operation, there may be chance that people find we are actually double angulator. So whatever it is, we just in product issues minus 1 into minus 1 plus 1, plus 1 into minus 1 minus 1. Like minus will be carried. Uh, so 1 into 1 total here it is 1, and so here plus 1. Okay, total it will be going to be minus 1. Maybe even minus of minus is actually plus into multiplication, right? So for this uh, we have to return 0. And whenever we have same number of odds, all are odds, we have to return size of the box. If the size of the box and the two, so same size of the box, right? Okay, he's just saying uh, we have to check the conditions. If the product of the elements inside an array, it has to be 1, and the second one is the summation of the elements inside an array is actually greater than or equal to 1. Or it contains positives and negatives values, both positive and negative values. If as it contains as the summation of the elements inside it contains greater than or equal to zero, that means negation elements are actually less than positive elements, right? So uh, just remember that one. Negation elements are actually less than positive elements. And here, product of integers is actually equal to 1. Equal to 1. We already in that dilemma. See, here, what if I have 3 minus 1s and 3 plus 1s? Even I divisible, I have minus 1 and 1. Besides, for into this whole term is represented as 1. But this minus 1, which is addition, and minus that, which is bad. It decides that. So, what should we do? We have to reduce, we have to perform the operation. What operation? We have to change one of the negative values to the positive values. That's all. Okay. For suppose if I change this one, okay. This is enough. These two are enough, and here only without power. Here, like it contains without power because this minus like how can I say odd number of minus ones, odd number of negative values actually gives uh, the value in like greater than uh, 1 or equal to 1. Okay, but whenever it contains uh, like uh, how can I put this? So we contains negative values. These are negative values. This is about negative values. If negative values is number of we have to think about its frequency, not the value inside it, right? So if the negative values are actually like we can say frequency. So frequency of negative values is actually greater than positive values. We have to do one step. And if it's whenever frequency is greater than the positive, we have to delete the minus one here and put the one here like that. We just have to change the minus one element into plus one. Okay, until this negative is actually less than or equal to become the positive side, positive values. Fine. And the another one is so it contains about whether uh, the n is actually what is the okay. Yeah, first test case. Number of positives is actually greater than number of negatives. Then, should we need to check the second test case? Like product of numbers is actually equal to 1. Okay, got it. We have to return, we have to find the frequency of ones and zeros. Is that ones and zero, frequency of 1 and minus 1. Like, besides that, we have to say like frequency of 5 bar, or how can I say frequency of what is that? Frequency of value, two unique values. One is less than value and another is greater than value. And we can say it as a negative value and another one is positive value. So int negative value, the first is 0 and positive value, it also 0. Okay. And here, if like extracted element from the user is actually less than 0, yeah, extracted element is actually less than 0, less than 0 or greater than 0. If it is less than 0, we have to go increment the number of positives, right? We have to increment the number of positives. Okay. And how many we are incremented? I'm sorry, that is not inside. We just have number of uh, negatives, number of negative value, and else so number of positive values. Okay. So whenever your extracted element is actually less than zero, then we have to. It is less than zero. We have so as it is less than zero, we have to increment the number of negative values, and whenever it is not less than zero, so like if it's greater than zero or equal to zero, we have to give number of positives, and then we have to return answer variable at first is equal to one, and we have to run a loop on what condition, on one condition, number of negatives is actually whenever it is greater than number of positives. So the number of negatives is actually greater than number of positives, then answer has to be incremented. Answer has to be incremented and in plus plus, and then finally what is that? So here an is the answer. We have to increment our answer. Okay, and we have to decrement our negative value, right? Negative value minus minus. Okay, and positive value plus plus. Now the cost we just shifting the minus one into the plus one. This is what happens. Okay, and this only uh, checks whether number of negatives is actually greater than number of positives. If even it is equal, okay, we just left it. Okay, if it is not, in order to we have to add that edge case also. Like whenever number of ones is actually odd, we should make a positive number. And in order to make a positive number from your number of cards, you have to extract positive. So we just have to remove one minus value here, like that. Uh, so what should we do? What should we do? And the number of negatives is actually greater than number of positives, and number of negatives is also not divisible by 2. So whenever it is not divisible by 2, okay, but whenever it is divisible by 2, what should we do? Yeah, number of here the it is actually under control. So let's run it on the test cases. Okay. What is that? Just impact. Let's run this. NP plus plus. NP was not declared. NP was not declared. Number of positive. Okay. NP was declared. Number of nation values. Number of positive values. Now you can get back. You can compile it. Array was not declared in this context. Do you mean not declared in this context? What is that? What is that? Okay, okay, okay. You're actually not getting counter. We have to was not declared. Here and B, uh, number of negatives, number of positives, and what do you have to do? Number of negatives and number of positives. We have to and find how many number of negatives and how many number of positives are there. And here, whenever the number of negatives is actually greater than number of positives, and number of negatives is actually divided by 2. Wait, let me submit this. What is, what's happening here? Control shift T to get the previous control shift T. Okay. This previous was on it. What is this? Sort down. Sorry. Uh, what we are doing? We just complete the writing code there. Uh, where is it? It's a submission one, and it's just written code. But here it is. Come on. Okay. Okay, let's rewrite the code again. We have cases and we have to travel on each test cases. So for each test case, we have to read a number n. Okay, and for after reading number n, we have to declare a vector of size n, and then we have to declare number of negatives and number of positives. Okay, good. So number of negatives, number of positives also equal to the same. Initially is 0. Now we have to extract elements. Okay. So extraction code C in extraction operator E of I. See, we already know it. And if A of I is actually less than 0, we can treat it as it is negative. Else, so it is greater than 0. So negative number of positives. Okay, good. After that, we have to return our answer and I equal to 0 and similarly go for I less than I plus plus. Okay, 0 and less than and for throughout the loop. Oh, sorry. Why we have to read a loop? And we have number of negatives and number of positives, right? So if number of negatives only whenever it is greater than number of positives, and uh, if it contains odd number of negatives, then odd number of negatives is actually uh, not equal to 0. So odd number of negatives, not equal to 0 means odd number of negatives, right? Then okay, then we should increase our answer and decrease the value of number of negative because we are actually putting that value into number of positives. So yes, right? Then n You just have to return the answer. Yes, it's not a written type. You just have to print our answer there, right? Let's try this on the test cases. Come on, come on, come on. Uh, Syntax set, right? Now, now it is what? NP plus plus at line number of 22 and line number of 23. In line number of 23, we have to end the statement with semicolon. We have to terminate the statement semicolon, right? This what? 1 1 1 1 0 1 1. Is it 1 1 0? Here it is 3. We have to perform 3 times. 1 1 0 1 1 0. After that, 3 here, not 1. For what test case? Like 1 1 0, and for as it contains -3, all are minus threes. Yes, negation is actually greater than positive. Number of negatives is actually greater than positive because here number of negatives only executed. And then if number of negatives is divided by 2, 3 is not divided by 2. Not when 3 is divided by 2, it is not actually 0. So when it is odd, and 3 is also odd, so we have to increment our answer. So one time we have to perform operation and shifting values, so n minus minus, which is 2, and n plus plus, which is 1 now. Now while loop again. So now negative numbers uh, are actually 2 is greater than 1. 2 is greater than 1. So and 2 is divided by 2 equal to 0. Okay, here this condition is actually executed. That's why the output is 1 over there. But we are not actually executing this reference for all. So we simply just change this operator. Any one of it's true, then we have to execute. Because if these two are executed, if these two are true, false. If any one of these one is false, we are actually go out of the go out of the like we are actually terminating this while 1103. Okay, now the three is appeared. Okay, let me submit it. Unary array. And so it's a kind of question like we have certain conditions, we have to apply those conditions on an array, and we have to check whether we are able to get the result or not. So here the difficulty is arises how can we actually find the pattern inside the conditions? That's what we have to understand first, right? See, according to this question. So these two are the conditions, and this is another one operation. Like we can shift -1 into 1 and +1 into 1. We don't need to bother. But in order to make the value greater than or equal to 0 after summation, we negatives has to be less than positives. So that's where we have to aware. That's the point. First point where we have given, and second point, the product of is actually the product of elements is actually equal to one, as it contains negative values also. It meant that negative one. So in order to avoid this negative one, we again there also yeah there also we have to shift that minus one into plus one. So that shifting process actually I'm writing here. The shifting operations. Yeah, I'm just shifting value, and this is for vector, and I'm taking elements into that vector, and these two are my new bodyguards. Their job is to find the racing and how to kill them. Just like that, but not exactly like here. These two are purpose is like counting the number of negatives and number of positives. After finding if number of negatives are actually greater than number of positives. Okay, you understand. Then we just have to shift that one of the number of negatives to the another set, which is a number of positives. Okay, that's what I'm implementing here. And here answer. Whenever we perform the operation, we have to implement the like this is the operation. This is the first time we performed it, and this is second time. That's why it is a plus plus. Right. Okay, and I already told you in order to contain think about it. This is for satisfying the plus operator, and this is for satisfying the negation operators. So it is also executes negation negation. Like whenever that number of negatives is actually divided by 2, whenever it is divided by 2, so yeah, here it contains positive or like even number of ones, but whenever it contains odd number of ones, it contains one more value than the even number of ones. So we have to this condition is actually fail. Number of negations is actually not greater than number of positives. But here this condition is actually this is false. It checks this is true. Whenever that number of negatives is actually divided by 2 and the value are actually 0, it says that it is a odd. So here number of negatives are actually odd. So as they are odd, what we have to do, we have to make them into even. Same operation, we just have to add uh, add one to the number of positive set and remove one to the number of negative set. So like this is, I hope you understand it. Okay. Now, so, twin permutation. What is twin permutation? Let's try to close this. Let's close on this. Twin permutations. You are giving me permutations of length. Find any permutation degree of length and such that. So we have to find the permutation B. Here permutation A is given for length n, and we have to find permutation B for same length and length, such that in this order A1 plus B1 and A2 plus B2, A3 plus B subs on A1 plus An. It can be proven that a permutation B satisfies the satisfaction the collision conditions. What is it? Let's try to grab the maximum information from the data. We have to do number of test cases, each number of test cases, and length of the permutation of A and B. So, both are having the same size, so n. And in the second test case, it contains distinct integers up to an from A1. So, the number of elements and all elements of A are distributed. So these all elements A are actually distributed. Note that there is no bound on a sum of array on all test cases. For each test case, output any permutation B, which transfers the constraints mentioned in the student. It can prove that permutation B that satisfies the condition above values exist. But uh, we have a permutation A of length m, Find permutation. We have to find permutations B, and okay, this is the main one we have to remember. So like permutation of A and the permutation of B for each element is actually less than that succeeding element until ending element. Okay, it can be proven that permutation of B satisfies the condition. Okay, we already know the definition. What is the permutation definition? Like so if value repeats more than one time, it's not in permutation. And if the values actually not differ, if like length of the value is not present inside the let, it is also not a permutation. Here the length is actually 4, but up to the 4 elements it has to be present, then only it will call as permutation, but here 2 is missing, so it is not a permutation. And n is equal to 3, but there is a 4 in the array. We already know this. Besides that, we understand what is a permutation and what is not a permutation. And up to 200 2000 test cases are there. So let's write code for 2000 test cases. And equal to 0. Let's see. Okay, sorry. We don't need to visualize that. Okay. Now on every test case, how to return, how to read the size L and vector of size, answer of size N in order to get the values inside a vector. Inside the vector and I plus plus. So we just that index. So this is how permutation A is assigned. Now what we need is permutation B, for whom we actually we actually did this. Because in order to store the result values in which we set, it is also same size as before. And now what we should do? We should do that. He clearly mentioned. Imagine this is a subarray, and this is also a subarray. Okay, then okay. So 0 and 1 and 2 and 3 and 4 and 5 and 6, and this is an permutation of A and this is permutations of B. Okay. uh, what the code was saying. So element at A1 and B1, summation of that element is actually less than or equal to the element at B. Osh, right? Uh, if you check it again, it's actually less than or equal to B. It's actually less than or equal to B, like our succeeding element. These both are they both summations actually less than or equal to their both summation equal to succeeding summation. Okay, good. So now we have to insert values into a baby Hulk because it's changed. Okay, how can I write in this code that? How can I? Okay, now we have some value in some value as n plus 1, n plus 1 is actually nothing but if 7 is there, so 7 plus 1, 8. Up to 8 we have to spend. Uh, and it's about complete. But now, from here we have to do the work filling the B vector. So how can we fill that B vector? Okay. For this, we have to again iterate over the array and uh, right. We have to choose like result set, result sum. Result sum is actually less than array of that sum, and we have to put that into new array. Okay, so this is what we've done in B. Okay, we're just putting element into this into the B vector. Now B vector is also filled, and care must be taken. It has to be less than or equal to others. Now, what we should do? He was asking like we have to print the negation array. Okay. Oh shit. Okay. Sorry. Um, I have to write in a for loop again. Shit. Only for loop. So writing for loop again. Uh, for what? For we have to print the B array of size n. Right. Here, if there is nothing to remember, then 0, then minus 1, whatever it is. Okay, then let's see. Let's copy and paste the uh, test cases here, and we'll see if it is satisfied, if it is run or not. Okay. Uh, okay, it's successful, but where is the output? Okay, after printing every element, we have print this. Now we have to run the code. So like now click on the run button. Why the return statement? Okay, sorry, return statement has to be here. We are not actually writing a class, right? And after printing, like we have to print an end line in new line. So black slash n. Okay. Okay. So where is the output here? You are fine. I think you get the output. Let's refresh. Okay. Where we are shooting it is. We are entering into the new line, and we have to repeat the process again. Yes. What is that? First we have. Okay. No, it's nothing but test cases. Here also we are not actually printing anything. Why? Isn't it B is actually initialized? B of I. Okay. Uh, Result of B of I. B of I is already and B of I is an element to element. Don't you get it? So here, uh, like A1 plus A2 uh, less than or equal to A2 plus A3, and A2 plus B2 is less than or equal to A3 plus B3. So every time the previous element has to be less than or equal to the succeeding element up to the n minus 1. And we have what we have here, these elements, and we have to arrange the elements here in permutation order so that this rule is satisfied, less than or equal to rule. Every time we have, so for every time we have to check, uh, we have to take an element here so that the addition of here already present element, and so we just add that we take an element to the array A to that same index, so 0 index element, and we have to check whether it is less than or equal to the succeeding element. Uh, uh, Here there is a point here. We can consider the equal to point. So it is simple, like if suppose x is a number, so it is hard to predict the less than number of x's, x numbers. We don't know this number, and it's really hard to find how many numbers are less than this number. Okay, but as x is a number, it is really easy to say, okay, x is equal to the x number. If the same, if we take the same number, it is equal to the same number. So this logic we are using here. Uh, Here I'm reading the values into the a vector, and here I'm building the b vector. See here how I'm building the B vector. I'm using RS, which is nothing but result sum, which is equal to n plus 1. Why it is equal to n plus 1? We already know that in permutation, the highest element is the largest element. So suppose is the size of the element. For suppose if this is an array and whose size is 5, then the highest element which is present inside the elements is also 5. So we are using that logic here. So as n is the largest number here, so we are taking largest number plus 1, and we have to subtract the that number, result sum number, from the a of I. I mean from the from array A for every index less than or equal to n. Then we get p. See how it actually implements here is, see here, suppose now let us take 1 2 4 5 3, 1 2 4 5 3, 1 2 4 5 3, and the largest element is 5, so 5 plus 1, which is equal to 6. So 6 minus 1, here it is equal to 5, and 6 minus 2 4, 6 minus 2 6 minus 4 2, 6 minus 5 1, 6 minus 3 again 3. So now if we add these two, we can get 6. This is also 6 6 6 6. That means the property is satisfied, whether the addition of the same indexes of both arrays resulting in less than or equal to the succeeding addition, right? So that's what we find here, and uh, it's really hard. I mean, not that much hard. Once we understand why we are taking n plus 1 here. Yeah, if you take n is nothing but 5. So 5 is the largest element. So 5 minus 1, 4. So here 5 minus, 5 minus 2, 3. So 4, 3, 4 plus 1, 5, 3, 4, 5. Okay, visible. And 5 minus 4. Here it is equal to 1, 5 minus 5, 0. Everything. Okay. It is also, I think it's going to be success also, because every time we are actually reducing a constant number. We are reducing a constant number uh, X. Here it is actually equal to RS, result sum, from the array of indexes. Then we get definitely the same number. The number which is going to be same after addition of both indexes of both arrays, right? So here I'm building a logic to put element inside the B, and here I'm actually printing the elements of B. So that's enough, and it's successfully accepted. Okay, so it is also solved. So thank you for watching this video, and if you have any doubts, just comment on this. I will try to explain.